go to Mrs. Cristina. What is it? Any question from Mrs. Cristina?
Yes.
I don't need a microphone.
Okay.
Sorry.
Because of recording.
No problem. I can speak loud, I guess. Okay. So, okay, where should I speak? Here or there? You showed in the introduction a picture, an image where there were some zones, and as I remember, there was something about the hydrogen.
Yes.
There was some hydrogen zone, but then you were speaking about the corrosion. So, is there a hydrogen, and if it is, how do you measure it? How do you know that the hydrogen is there? Because your solutions and the corrosion. So, I mean, it's either hydrogen, either corrosion due to, this is two other, how to say, two different things. Or do you have both of them or just one? Could you please clarify this?
In aluminum alloy 2024, it was found that there is a synergetic effect. Yes. Okay.
Thank you.
For the aluminum alloy 2024, that the picture were about in another research, yes, it was found that there was a synergistic effect, both of notches and hydrogen brittle zone because of the hydrogen diffusion. But on the 2198, the aluminum lithium alloy, we didn't found something like this yet. It is under investigation, the corrosion behavior, and to search if there is this hydrogen brittle zone.
And maybe this is some kind of a recommendation. Have you used acoustic emission in your studies? Because it's super and really efficient and sensitive for corrosion and hydrogen embrittlement.
No, I didn't use.
I could recommend this really because you can hear even every bubble with it.
Yes.
Thank you.
Okay, thank you.
Another question, please. This is your guest.
Yes, may I comment on Christina?
Okay.
Actually, I have to comment on Christina, meaning that corrosion hydrogen embrittlement is absolutely the same mechanism. Due to corrosion, hydrogen is being produced because of the outer surface. It breaks the anodic film, and then the generated hydrogen is being diffused into the center of the specimen. So it's absolutely the same mechanism. If you have a pitting, then the hydrogen front goes deeper into the center of the material. So the higher pitting you have, then it acts as a well, that hydrogen goes deeper. I have to confess that for 2024, the previous alloy that I make a presentation, it's already mature, that is hydrogen brittled. For 2198, still I don't know any publications dealing with this subject. And how do you measure hydrogen? Of course, you can measure it with heat transfer and some concentrations with ppm, but still this is something where laboratory of mechanics who cannot perform just like this. So we simply measure the mechanistic approach, the mechanical properties. Okay, and that's the way Christina performs low exposure time, only 2 hours, just to avoid pitting and have the excess of ductility decrease by the hydrogen embrittlement.
Thank you very much. We have 7 minutes, so we go directly to Mr. Nicholas.
So I'm the next. Okay.
Please, any question from Mr. Nicholas? It's the same subject, I think. But we need the questions, please.
I could only ask to continue your question. It's really not clear for me. So we have a pitting corrosion, and this is the growth. The pit is growing somehow. This is one thing. And the other thing, hydrogen embrittlement, when hydrogen just changes the field of dislocation so they can move to each other closer, and the plasticity is increasing. So this is, to my point of view, two different things. I don't know how.
To my understanding, it's hydrogen is being transported through grain boundaries or I don't know, to the center of the material. And there are some, according to the literature, there are some traps, some hydrogen traps, that according to the condition, to the aging condition, it could be the interface of the precipitates. It could be some vacancies in the atomic microstructure or at the grain boundaries. But yes, we do know that hydrogen is being transported, is diffused actually to the center of the material.
I mean,
have I covered your...
The pit, when the pit grows, it's a chemical process. And
Exactly.
hydrogen embrittlement is a mechanical plasticity process. That's what I meant. Am I right?
Yes, from my from my understanding, hydrogen embrittlement is actually hydrogen being diffused to the material, to the microstructure of the material, and locally, the plastical deformation is reduced. This is what we call embrittlement. So lower capability for fracture.
Maybe we could discuss.
Yes, again. Yes, it's a consequence. Yes, exactly.
We have chips and we can continue after in the chip.
Okay, just one small question. You showed us the paper was entitled as effect of solid solution subsequent artificial aging heat treatment of the fracture resistance
Yes,
of pre-corroded 2024 aluminum alloy specimen. My question is, do you have any experience with, for example, friction stir welded specimens or welded specimens at all? Because there we have variety of microstructures, we have variety of second phase particles, and any kind of solid solution is, well, trying to not to compare, but to make everything even, to make everything the same. So, do you have any experience in that?
Yes, I will reallocate you on Thursday. Thursday morning and Thursday afternoon, there are two publications from my students. The one is dealing with welding, not with friction, is something that we are working right now. We had a project with Hellenic Aerospace Industry, and they worked on with electron beam welding, and the effect of artificial aging on the corrosion resistance of the welding. And there is a PhD candidate behind you that's working at Helmholtz Institute, working with laser beam welding on 2198.
Because our
Yes.
our experience for exfoliation
Yes.
tests and everything was something like this. When you have the results, you see that the cracking occurs sometimes even in the nugget zone, depending on how severe corrosion test was. So basically, the critical place as a thermomechanically affected zone or near net to nugget zone is now something else. So it's rather a question of what the gentleman said. We have here two things. One is chemical nature. The second one is thermomechanical nature. So depending where the governing process is going, we have different outputs. And that is probably the nightmare for everyone who is a designer in mechanical engineering. I mean, I'm a metallurgical engineer, okay?
Yes.
So my knowledge and my ideas are stopping there. It's the other people who have challenge.
Exactly. On Thursday, Eva will show you some pictures showing localized corrosion on the heat-affected zone, while the fusion zone is unattacked. by corrosion. And we have performed also artificial aging on the weldments, and she performed also tensile tests. And this is a complex phenomenon. We try to give a small solution. We cannot solve everything, of course.
Thank you very much. Thank you very much, Professor.
No more questions.
Okay. So we move to Professor Koizumi.
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 Yeah.
Please. Any question from Professor? We talk about intergranular and transgranular fractures. Please, just one question. Any questions? No? We have 3 minutes. Okay. Thank you, Professor.
Thank you.
We move to Mr. Professor Warner. Please. Questions, please. Questions.
I'm sorry, I came late.
Okay.
I was on the other session.
Oh, we are so sorry for
I
you.
was in the warm session, so here is the coldest one I have ever seen.
But we can make abstract for you.
I would,
Okay. Thank you very much, Mr. War. And we move for me. Any questions for me, please? I have presented the work of my PhD student. Any questions? Okay, thank you very much. Happy to see you here and enjoy your visit to Belgrade. Thank you very much.